So let us understand the working of PLL. So here we are plotting the transfer characteristics of PLL. The word transfer means output, the relation between output and input. So here we are giving frequency as input, and in previous slide we have seen that we are taking the control voltage as an output, demodulator output. So here also you can see the same diagram just for reference. Now as you see here, on x-axis we have Fin, on y-axis we have control voltage, and we have just marked some of the frequencies. So here at the center you can see the free running frequency F0, then you see the frequency F1, F2, F3 and F4. So later on you will understand the importance, or rather the concept of F1, F2, F3, F4. So before going to the actual concept or how the PLL works, let me give an analogy. So in real life example, we can actually, from the real life examples, we can actually understand the concept of PLL. So let me give a couple of examples so that you will understand the concept of PLL. Just recall, or rather imagine, the game of cricket. Now batsman is batting, bowler is bowling to the batsman. And you must have noticed that when a bowler bowls a wide ball, or the ball which goes far away from the batsman, does the batsman attempt to play the shot? Absolutely not. So I repeat, batsman is batting. Imagine the situation where bowler is bowling a wide ball. So batsman doesn't attempt, or rather don't attempt to play the shot. That means he simply ignores. So that mode, you can imagine, like batsman is least bothered about that ball, that situation. You can call this as free running. Batsman doesn't take any action. So let us term this as free running. Later, suppose next ball comes little closer than the wide ball, and now it is in the crease where batsman can attempt to hit the ball. So you must have noticed when such ball is bowled, the batsman really try to hit the ball. So he basically track the ball and hit the ball. But that hitting may not result in more runs, but at least we can say that he started tracking the ball because ball is within his range. Let us call this as a capture. So earlier situation was free running. Now second situation I have put forth in front of you is a capture, where the batsman can track the ball and try to hit. The third situation you can imagine, where a bowler bowls a ball perfectly on the bat, and there batsman can hit perfectly to result it in the either 4 runs or 6 runs. That we can consider as a perfect locking. So we got the 3 state. One is free running, where batsman was least bothered about the ball. Second case, when the ball was in the crease, so that batsman can attempt all such balls. So let us call this as tracking, or we define this as capture. So when the ball is in the range, the batsman started taking action. So that is called as capture. And the third is a perfect lock, when he could hit the 4 or 6. So here I have introduced the concept of free running, capture, and lock. Let us see one more example. Imagine a 400-meter relay. So in relay, if it is 400-meter, and if every player has to run for 100-meter, then you must have noticed there are 4 players. The first player starts from 0th position, run for 100 meters. Then he has to pass the baton to the next player, who runs for another 100-meter, and subsequently again he has to pass the baton to the third player, and so on and so forth. So this is about 4 by 100-meter relay. There also you must have noticed that when the second player actually wishes to take the baton from first player, the second player doesn't actually stand at the 100-meter mark. So he always stand 10 meters before this 100-meter mark. Let's say at 90-meter mark. Why? Because you must have noticed, when first player actually starts the race or start running, the second player is least bothered, because he is not in range. But as soon as the first player approaches the second player, say 70 or 80-meter mark, immediately the second player starts gaining attention. As soon as the first player touches the 90-meter mark, the second player also start running along with the first player. That again you can consider as a capture. So first was free running, when second player was not paying any attention to the first player. But as soon as first player comes in the range, he started paying the attention. So we can call this again situation as capture. And then perfectly at 100-meter mark, both are in very synchronization. So you can consider it lock condition. And that time, the first player handovers the baton to the second player. So in many examples, we can actually see this effect: free running, capture, and perfect locking. Always it is going to be there in the real life examples. Another common sense or a common example that you can see, that I definitely want to share, is, suppose imagine that you are in the party, a DJ is playing the music, but that music you are not interested in. Suppose you are very much fond of Kishore Kumar's songs or old songs, and specifically Kishore Kumar, but he is not playing those songs. So what will happen? You will not pay the attention, and you will be least bothered, and you will be continuing with your own activity, that is free running. Later that DJ changes the song, and suppose he is now playing some old song, maybe of say Lata Mangeshkar or Rafi. And since you are fond of old songs, doesn't matter if he is not playing the Kishore Kumar song, but still you start gaining the attention, and then you are tracking what he is playing. So there your action started. So you are capturing, since you see that the data is within the range, or the situation is in the range, and that's why you are trying to attempt, trying to track that. And later on, when this DJ, fortunately, if he plays a Kishore Kumar song, immediately you find it as a perfect locking condition, and definitely you will be overjoyed. Whatever I have discussed through these three examples, always you have observed a free running mode, then you have capture mode, and then locking condition. The whole effect is called as selective filtering. So always we do the selective filtering in the real life examples. So I hope you have understood little bit the concept of how the selective filtering does or tracking filtering does. PLL works in a similar fashion, and again you have three modes here. You have free running mode, capture mode, and lock mode. So let us understand the working of PLL now. So I am playing here, or rather experimenting here. What I am going to do is, I am going to start with zero frequency, and input frequency I am going to change. So here you can refer the diagram. So VCO frequency is set to F0. So now VCO is freely running, and suppose its frequency is F0. Okay. And input frequency I am going to change gradually from 0 to this. So initially I will increase the frequency, reach to this frequency, then this frequency, then make the frequency exactly equal to F0, then go beyond F0 and continue to increase the frequency further. And I'm going to watch the control voltage. So on y-axis we are plotting the control voltage. So this experimentation, we call it as a forward experimentation or forward path. Okay. So blue color represents this, the whole journey.